Um, Suppose I've got a triangle right here with sides A, B, and C, and I'm asked to find the area of this triangle. We know that area of the triangle is equal to half times base times height. Here, the base is C, that we know, but the height is unknown. Height is unknown. So, how will we find the area of this triangle? Um, for this, we have a formula, what Heron called Heron's formula. It is given by the square root of s into s minus a into s minus b into s minus c, where s is half of the perimeter of this triangle, that is a plus b plus c divided by 2 is s, and is s, and the ABC are the respective sides of this triangle. So um, this formula is nothing but derived from this formula itself. Um, this shows a relation between the three sides of the triangle and its area. Now I will show you that how this formula has been derived from this. So here we have a triangle, the triangle and the area is this, and we need to prove that root square root of s into s minus a p into s minus c is area of this triangle. So let's start. Let's say that the distance between this and this perpendicular distance and this height is, say, at x. So this distance would be c minus x, and this whole is c, then this will be c minus, obviously c minus x. And so we are, by using Pythagoras theorem, we write here equation that hypotenuse square is equal to base square plus perpendicular squared. So here we have that, and in this triangle, this I'm talking about this, a squared is equal to x squared plus h squared, and similarly in this triangle, um, this h squared plus c minus x squared is equal to b squared. So here we have the two equations. Now we need to substitute some values here and there and find the value for h and put in that half into base, and then we would get this formula. Here we go. From this equation we have that that h squared is equal to a squared minus x squared. Now we shall substitute this value in this equation. Let's name it second equation, and then we'll further solve it. And now substituting the value for h here, so b squared is equal to a squared minus x squared plus c minus x whole squared. So we have here, right here, we have substituted the value for h squared here. This is equal to a minus b whole squared, that is equal to a squared plus b squared minus 2ab, that is cx. Now this as it is. Now here minus x squared and positive x squared we have cancelled. So now we have here that b squared is equal to a squared plus c squared minus 2cx. Now we need the x right here because we want to substitute for x right here, x from there, and we will take all this equation that side. So b squared minus a squared minus c squared is equal to minus 2c. So it's a multiplication, then we'll take it that side next step. So b squared minus a squared minus c squared over minus 2c is equal to x. So we have this equation, final equation here. And now we're gonna put this equation in that. that b squared minus a squared minus c squared upon minus 2c is equal to x, and in the first equation we had that a squared is equal to x squared plus h squared. Now we are going to find the value for h right here. Now we will substitute for x here. First take that side. So a squared minus x squared is equal to h squared. Now we have here substituting this from here, we can take this a squared minus b squared minus a squared minus c squared upon minus 2c whole squared is equal to x, and is equal to h squared. Now solving this, further on solving this, we shall take this, we can take this minus on the numerator side. This will become minus b squared positive a squared and positive c squared upon 2c this whole square is equal to h squared. And so from right here we have that only h is equal to under root of this all, and the value of h is equal to under root square root of this all. And now taking this value of h, and we will put it in the formula that we have half into base times height. So let's do. So we had that either triangle is equal to half times base times height, and we have the height is equal to a squared minus square root of this all. And now we're gonna substitute this value in this. So the area of the triangle would be half times base, and the base was base of our triangle was c. So half c times height, running this all right here, and a squared minus b squared plus a squared plus c squared upon 2c and this whole square. Now if I square it and put an under root, then there's no effect on the calculation, so that we could put it in under a single root. So we have right here, we can write this and this. So after squaring it, we get c squared upon 4 and whole under root right here, since it is in multiplication, so we can write it like this, into a squared minus b squared plus a squared plus c squared upon 2c and this whole squared. Now distributing c squared upon 4 here, and we have opened the bracket right here. A squared c squared upon 4 minus c squared upon 4 and this whole into minus b squared plus a squared plus c squared, and this is equal, so if we open the bracket right here, we have this squared and over 2c squared, and we can write this as 4c squared right here, and we get that c squared can be cancelled with c squared, and we have here 4 and 4 right here, so we get 16. 4 squared, let me do it the second step, upon, now here we get minus, so we have in the denominator that 4 into 4, that is going to be 4 squared, and I'm going to write this whole in the bracket right here, so b squared plus a squared plus c squared upon, this is going to be 4 squared, this bracket here, but I'm going to combine it all and write the square here. So if we see this equation carefully, and we can write it as ac upon 2 whole squared minus, and the same we have here, b plus a for this whole squared. This is nothing but this partial sum, that is a squared minus b squared is equal to a plus b into a minus b. So this is going to be equal to AC upon 2, that is whole is equal to A, and this whole is equal to B, and A squared minus B squared is equal to A plus B. I'm going to write the signs right. This is this only, that minus B squared A plus B into A minus B minus B squared plus A squared. This whole right here. And now we have to now simplifying this. So we have that AC upon 2 plus minus B squared plus A squared plus C squared upon 4 into AC upon 2 minus B squared plus A squared plus C squared upon 4 under the square root. So we can write this. We multiply the denominator and the numerator by 2, so that we can get the denominator same for both the fractions by 2. So we get here 2AC upon 4, 2AC upon 4. We can write it under common denominator. So here we get that 4 upon 2AC, and if we open the bracket we get that minus B squared, because we have the positive sign here, the signs will remain the same, plus A squared plus C squared, and this as 2AC, this whole upon 4, and since we have the minus sign, the signs inside the bracket will change, plus B squared minus A squared and minus C squared, this whole in the square root. So if we carefully see it, that this is nothing but if we rearrange it like this, A squared plus C squared, and we have the positive sign here, plus 2AC minus B squared upon 4, and minus B upon 4, and into this, we write this as minus A squared minus C squared plus 2AC plus B squared, this whole upon 4, and this is going to the square root. And now if you see, if we take the minus in common bracket right here, and the signs we are going to change here, positive sign here and negative sign here. So if we see that A squared plus C squared, this is nothing but the expanded form of A plus B whole squared, that is A plus C whole squared, and similarly this is. So we are going to rewrite this as A plus C whole squared minus B squared, this, sorry, like this, and this upon 4 into, and this as A minus C whole squared, and since we have this negative sign in common right here, we will put it right here, plus B squared. So if we see that this is nothing but A squared minus B squared, and this, if we rearrange this as, we write B squared first and minus A minus C whole squared and the second, and we will get this B squared minus A minus C whole squared, that is going to be A squared minus B squared and equal to A plus B and A minus B. So we can write this as A plus B into A minus B, this whole upon 4, and this in the multiplication with this, we'll write this as A plus B into A minus B, and if we open the bracket right here, we will get positive C, this whole upon 4. These all things are under square root. Square root. And if we see that we can distribute 2, we can write this 4 as 2 into 2, and this also as 2 into 2. So if we take this 2 under the denominator of this all, since it is multiplication, we can write this as by rearranging a plus b plus c upon 2. This is going to multiply with a plus c minus b upon 2, and this with a plus b minus c upon 2, this b plus c minus a upon 2, this whole in the under square root. So now if I write this as it is, as a plus b plus c upon 2, and if I rewrite this as a plus c plus b minus 2b, and this is going to be equal to minus b only because this minus 2b plus b is equal to minus b. So I'm writing this for the sake of convenience as minus 2b plus b. Similarly, here also I write this as a plus b plus c minus 2c upon 2, and same right here, b plus c plus a minus 2a upon 2. And now this was under square root, and this same like a plus b plus c on 2 into, and now if I take this this number apart from this fraction and make it separate, I could write it as c plus b upon 2 minus 2b upon 2, and this 2 is going to be cancelled with this 2, so for better I write this as minus b. And similarly right here, a plus b plus c upon 2 minus c, the same way I wrote this one, and same right here, a plus b plus, I'm rearranging this all, plus c upon 2 minus a, the same way. This was under a square root, and so if we see here that a plus b plus c upon 2, and we know that a plus b plus c upon 2 is the value for s we are finding for. So if we substitute this a plus b plus c upon 2 with s right here, and we will get s into s minus b into s minus c into s minus a. This was whole under the square root. So finally put it like this, and after rearranging it, and we finally get the Heron's formula right here, that is s into s minus a into s minus b into s minus c. Here's that. So now I've got a question here that find the area of the triangle with sides 8 cm and 11 cm and perimeter 32 cm. So let's draw a triangle right here. We have that the sides are 11 cm, 8 cm, and the perimeter is equal to 32 cm. And this side is unknown. We know that. Let's name it as A, this as B, and this as C. We know that perimeter is equal to sum of three sides, that is A plus B plus C, and this is going to be equal to 11 plus 8 plus C is equal to 32, and 11 plus 8 is equal to 19 plus C 32, and here we get the subtract 19 from 32. We get the value of C, that is equal to 13. C is equal to 13. Now we're going to solve this by using the Heron's formula. Using the Heron's formula, the area of the triangle is equal to S into S minus A into S minus B into S minus C. And the half of the perimeter, that is 32, so S is equal to 16 centimeter. And now taking the values right here, 16 minus A is equal to 11 into 16 minus B is equal to 8, and C is equal to 30. Now solving this, we get that 16 minus 11 is 5, and 16 minus 8 is 8, and 16 minus 13 is 3. Now multiplying this, we have 16 into 5 into 8 into 3, that is equal to 1920 under root, and the under root value for 1920 is 43.81. That's the approximately value for this. So the triangle with the sides 11 centimeter, 8 centimeter, and 13 centimeter has the area equal to 43.81 centimeter squared.